So next up, we're just going to do some linear algebra basics. So just super basic things with linear algebra. First, we're going to talk about a scalar. A scalar is just a fancy name for a regular number. It's just your standard 1, 2, 3, 4, just standard number, contrasted with a vector. So a vector has magnitude, direction. So a vector is just an arrow, essentially. So an arrow that has direction and a magnitude. So by direction, it just means it's going to some place. So these are all examples of vectors, and these are what you call like scalars, just like single numbers like this. You can multiply any scalar by a vector to increase the scale of it, or just scale it. So like you can say, oh, I'm going to multiply this vector by 2, so you get this, and then you end up with this, right? So you can scale your vector. The other important parts of vectors is the directions that they can be in. So you have two possible directions vectors can be in relation to each other. They can be parallel, which we won't really talk about, or they can be perpendicular. So we can test for perpendicular vectors by using this thing called a dot product. And the dot product would just be equal to 0 for perpendicular. But what's important about these vectors is not so much testing if they're perpendicular, but making them perpendicular. And you might be like, why? Why is that important? So say I have a superpower in a game, right, that I want to take this person and I want to shoot them against the wall, but it wouldn't make sense if they bounced right back at me, right? I would want them to bounce out at a 90-degree angle to the different direction. So what you want to do there is you want to be able to figure out what the perpendicular vector is, so that your entity can move along that line. So how do we find our perpendicular vector? What we do is relatively simple. It's just about moving around each component of our vector. So there's going to be an x part of our vector, a y part of our vector, and a z part of our vector. So this just denotes x direction, y direction, and z direction from, let's just call it the player, right? So the player is the origin point. So basically what we're saying is that this player shoots out vectors or superpowers in directions denoted by x, y, and z. So x, xy plane, and then our z, of course, is our height. So we need to take this vector and we need to alter it. And the way that we alter it is we change our x and y components, because we want x and y to be orthogonal or perpendicular, but we don't really care too much about z. So I'm not really thinking about z. So in our example where we just want to go off in a perpendicular direction, we still want to go up. We want to go up from us and then up from there. So we're not going to touch z, because z's normally are up and down. So what we do is we flip. So we have negative y for our x, and then we have negative x for our y, and then we have z. So we leave z alone. So we're always leaving alone one component here.